Hello everyone, I am James Cruz Olivares and I am engineering student from Colegio de Muntinlupa, and now I will discuss the topic of using bending flexible concrete in construction. And now let us proceed to our introduction. What is flexible concrete? Flexible concrete, also known bendable concrete, an engineered cementitious composite or ECC that exhibits the property of ductile material unlike the brittle nature of the conventional concrete. The material composition of conventional concrete is altered in order to impart flexible nature in concrete. And what is bending flexible concrete? Bending flexible concrete, also known as a bendable concrete or flexible cementitious composites, is a type of concrete that exhibit enhanced flexibility and ductility compared to traditional concrete. It is designed with withstand bending and deformation without cracking or breaking. Bending flexible concrete is typically composed of a mixed cement, aggregates, and additives that enhance its flexibility and durability. These additives may include polymer fiber, synthetic fiber, or reinforcing materials that improve the concrete's ability withstand bending forces. And now we are going to conventional concrete and bendable concrete. What is conventional concrete? Conventional concrete, also known as a normal concrete or traditional concrete, it is the most commonly used type of concrete in construction. It is composed of a mixture cement aggregates such as sand and gravel, water, and sometimes additional admixture. And bendable concrete is achieved by incorporating fiber into the concrete mixture. This fiber can be made of various materials such as polymer fiber, steel fiber, or even natural fiber like bamboo or sisal. Tensile strength to the concrete, allowing it to flex and bend without a failure. Here are some key reasons why bending flexible concrete is important. And the number one is crack control. It is traditional concrete is prone to cracking under stress, which can compromise its structural integrity. Bending flexible concrete, on the other hand, exhibit a superior crack control due to its unique composition. It contains a network of fine fiber that distribute stress more evenly, reducing the likelihood of crack forming and propagating. Enhanced durability. It is the ability of bending flexible concrete to resist cracking and deformation, make it highly durable. It can withstand a wide range of environmental conditions, including a freeze-thaw cycle, seismic activity, and chemical exposure. This durability translates into longer service life and reduce maintenance cost for structure. And the number three is increased design flexibility. Bending flexible concrete offers greater design flexibility compared to conventional concrete. Its ability to bend and deform without fracturing allow for the creation of more complex and innovative architectural shapes. This opens up new possibilities for architects and engineers to create aesthetically and pleasing and structurally efficient designs. Then the number four is improved seismic performance. Earthquakes can exert significant forces on structures, leading to catastrophic failure. Bending flexible concrete has shown a promising performance in seismic events due to its ability to absorb and to dissipate energy through controlled cracking. This can enhance the safety and resilience of buildings in earthquake-prone regions. The number five is a suitable construction. Bending flexible concrete is considered a more suitable alternative to traditional concrete. Its crack control properties reduce the need for maintenance and repairs, resulting lower materials consumption and waste generation. Additionally, the use of the fine fiber in its composition can partially replace traditional reinforcement, reducing the overall carbon footprint of the material. Then the last one is cost effectiveness. While bending flexible concrete may have a slightly higher initial cost cost compared to conventional concrete, its long-term benefits can outweigh the initial investment. Chemical composition and additives. Number 1, polymer additives and their role. The most common polymer additives are stabilizer, plasticizer, and flame retardants. Stabilizers are added to prolong the useful life of a polymer formulation by protecting it from thermal and light-assisted oxidation. Polymer additives are substances that, that are added to polymer during their processing or manufacturing to enhance their performance or modify their properties. These additives can serve various purposes such as improving the polymer strength, flexibility, durability, flame resistance, UV stability, or processing characteristic. And, and also, uh, there are several types of polymer additives, each with a specific function. Number 1 is plasticizer. These additives increase the flexibility and workability of polymer by reducing their glass transition temperature. Plasticizers are commonly used in PVC or polyvinyl chloride to make it more flexible and easier to process. The number 2 is stabilizer. Stabilizers are added to polymer to prevent degradation caused by heat, light, or oxidation. They help maintain the polymer physical and mechanical properties over time. Example including UV stabilizer, heat stabilizer, and antioxidants. Then the number 3 is flame retardants. These additives reduce the flammability of polymer, making them more resistant to ignition and slowing down the speed of flame. Flame retardants are commonly used in application where fire safety is critical, such as construction materials and electronics. Then the number 2 of chemical composition and additives. Number 2, a superplasticizer and workability enhancement. Superplasticizer are commonly used in dry press concrete to improve the workability and to enhance the compaction of concrete for increasing density and improve the surface finish of the concrete product. The main purpose of a superplasticizer is to reduce the amount of water required to achieve a desired consistency in concrete mixture by dispersing and separating the cement particles more effectively. A superplasticizer enhances the fluidity and workability of the concrete. And then the number 3 is reinforcement for bending resistance. Fiber reinforcement is a technique used to enhance the bending resistance of material. When a material is subjected to bending forces, it experiences tension on one side and compression on the other. This can lead to crack, deformation, or failure if the material is not strong enough. By incorporating fiber into the material, its bending resistance can be significantly improved. Fibers such as glass, carbon, or aramid fiber are typically embedded within a matrix material, such as polymer or concrete, to create a composite material. The fiber act as a reinforcement by distributing and transferring the bending load throughout the material. They resist the tensile forces on the outer surface of the material during bending, preventing crack and fracture from forming. This reinforcement mechanism helps increase the material's ability to withstand bending forces without breaking or deforming excessively. Bending flexible concrete chemical reaction. The chemical reaction involved in the formation of bending flexible concrete are similar to those in conventional concrete. The primary chemical reaction is the hydration of cement, which occurs when water is added to the cementitious mixture. This reaction leads to the formation of a solid matrix that binds the aggregates together and gives concrete its strength and durability. During hydration, the main chemical compound compounds in cement such as tricalcium silicate or C3S and dicalcium silicate or C2S reacts with with water to form calcium silicate hydrate or CSH gel. This gel fills the spaces between the cement particles and aggregates, providing binding and strength giving properties of concrete. The CSH gel is responsible for the development of the concrete strength and acts as a glue that holds the aggregates together. The calcium hydroxide or CH formed during hydration is byproduct and contribute the alkalinity of the concrete. In this case, the bending flexible concrete additional chemical reaction may occur depending on the type of fiber used. For example, if the steel fiber are incorporated, they may undergo a passive oxide layer formation to protect against corrosion. Uh, Polymer fiber may not undergo chemical reaction but contribute to the overall flexibility and ductility of the concrete. It is important to note that the chemical reaction in bending flexible concrete are similar to those in conventional concrete with the primary difference being the addition of fiber to enhance flexibility and ductility. The chemical reaction involved in the hydration of cement can be summarized as follows. Advantages of flexible concrete. Flexible concrete has advantages, but what are the advantages of the flexible concrete? The flexible concrete has the ability to bend like a metal. It is more stronger, more durable, and lasts longer than conventional concrete. It has the self-healing property that is it can heal itself by using carbon dioxide and rainwater. It is not brittle like a glass. It is more resistant to cracking. It does not emit that amount of harmful gases as compared to conventional concrete. The flexible concrete is approximately 20 to 40% lighter. This this use of steel reinforcement is reduces and can be eliminated. It reduces the cost of the project. It can be used as precast concrete. Disadvantages of flexible concrete. Then lastly, flexible concrete has a disadvantages. But what are the disadvantages of the flexible concrete? It has a high initial cost as compared to conventional concrete. It requires skilled labor for its construction. It needs some special type of material which can be difficult to find in some areas. Its quality depends upon the material used and the condition under which it is made. And then last, it is compressive strength can be lesser than the conventional concrete. Again, I am James Cruz Olivares, and I hope that you have learned something about this topic using bending flexible concrete and construction. And that's all. Thank you and God bless.